Hey everyone, and welcome. Today, we're going to tackle one of the coolest, most powerful concepts in Java, polymorphism. Now, I know it sounds a little intimidating, but we're going to approach this like a detective story. We're going to uncover clues that will help us write code that's way smarter and way more flexible.
So let's set the scene. Picture this. You've done everything by the book. You've set up this awesome family of classes using inheritance. They all have a common ancestor. It's perfect. But then you ask them all to do the same simple thing, and you get back this really boring, generic answer that's missing all the good stuff. It's that classic moment where you just think, what went wrong? Well, that's the mystery we're here to solve today.
All right, so our story starts with a simple goal and, of course, an unexpected glitch. We're going to see how inheritance gets us most of the way there, but also where it kind of hits a wall.
Okay, so here's our setup. We have a general class called item. Just think of it as the main blueprint for anything in our media collection. It's got a title and a comment. Then we get more specific. We've got a CD class and a video class, and they both inherit from item, so they're specialized versions of an item, and they add their own unique details, like an artist for the CD or a director for a video. Seems totally logical, right?
And this is where we see the problem firsthand. Over on the left, that's what we want to see. For a CD, we want the artist, the number of tracks, all of it. But on the right, well, that's what we're actually getting. Just the title and the comment. All those important specific details are just gone. So what's going on here?
Here's the heart of the issue. The print method we're calling actually lives inside the parent class, item. And the item class, well, it only knows about the things it defines, the title and the comment. It has absolutely no idea that its kids, CD and video, have extra fields like artist or director. Information flows from parent to child, but not the other way around. Inheritance is a one-way street.
Okay, to really crack this case, our detective work needs two key clues. These are the concepts that are going to help us diagnose exactly what's happening behind the scenes. Let's talk about static type and dynamic type.
First up, we've got static type. This one's pretty straightforward. It's the type you, the programmer, actually write down in the code. It's the variable's official type, what's on its name tag. The Java compiler looks at this static type to make sure everything's legal, to check the rules before the program even runs.
And then we have its partner in crime, the dynamic type. This is what the variable actually is when the program is running. You can think of it this way. The static type might be the label on the box, but the dynamic type is what's actually inside the box, and that difference is everything. Let's make this super clear with a simple example. Let's say we write vehicle v1 equals new car. The static type is vehicle. That's what we wrote down, that's what the compiler sees. But at runtime, what kind of object did we actually create? A new car. So the dynamic type is car. The label says vehicle, but the object itself is a car.
Okay, so let's bring this back to our mystery. When we put all our CD and video objects into a list of items, their static type is item. So the compiler looks at our code and says, okay, you're calling a print method on an item. Let me check. Does the item class have a print method? As long as the answer is yes, the compiler is happy and moves on. It doesn't care that the object might really be a CD underneath. And that right there leads us straight to the breakthrough. This is the aha moment, the solution to the whole puzzle. It's a technique that just perfectly solves this conflict between what the compiler sees and what the program needs to do. Let's talk about the power of overriding. So check this out. The solution is to put a print method in the parent class and in each of the child classes. We keep the one in the item class. That makes the compiler happy because the static type has the method it's looking for. But then we also add a specialized print method to both CD and video. This is the absolute key.
So what is overriding? Well, it's when a subclass, like CD, defines a method that has the exact same name and parameters as a method in its parent class. The compiler sees the parent's method and gives you a thumbs up. But when the code actually runs, Java is smart. It looks at the object's dynamic type, what it really is, and calls the more specific version from the subclass. It basically says, I'll use this special one instead.
So we know what the solution is, but how does Java actually pull this off? Let's pop the hood for a second and see the exact process Java uses to figure out which method to call. This is called dynamic method lookup.
Let's start with the easy stuff. On the left, if we have a video object stored in a video variable and we call print, Java looks in the video class, finds it, and runs it. Simple. Now on the right, imagine video didn't have its own print method. In that case, Java would look in the video class, not find it, and then climb up the family tree to its parent, item. It would find print there and run that one instead.
And this. This is where the magic happens. Remember, our variable's static type is item, but it's holding a video object. That's its dynamic type. When we call print, Java starts its search with the dynamic type. It goes straight to the video class, it finds the specific print method we put there, and it runs it. And since it found what it needed right away, it just stops. It doesn't even bother looking up at the generic print method in the item class. So let's just lay that whole process out step by step. First, Java looks at the variable. Then it finds the actual object it's pointing to. Step 3, it figures out that object's class, its dynamic type. Then, and this is the important part, it searches that class first for the method. If it finds it, awesome, we're done. If not, and only if not, does it climb up to the superclass and start the search over again. This whole process guarantees the most specific version always wins. All right, so knowing the mechanics is one thing, but let's talk about mastering the craft. How do we use all this stuff to write code that's not just working, but is also clean, efficient, and, well, professional? So we've solved one problem, but you might have noticed we've kind of created a new one. I mean, the item class already knows how to print the title and comment. Our new print methods in CD and video also have to print the title and comment. We're not just going to copy and paste that code, are we? That's messy, and it's just asking for bugs down the road. There has to be a better way. And of course there is. This super keyword is our secret weapon for clean code. From inside a method in, say, the CD class, you can write super.print. That tells Java, hey, go run the version of this method for my parent class first, so our CD's print method can call super.print to take care of the title and comment, and then it just adds the lines for the artist and tracks. No duplicated code, just beautiful, layered functionality. This whole idea of a parent and child class sharing and working together brings up another really important topic: access levels. We all know public means anyone can see it, and private means it's totally locked down inside the class. But there's a middle ground: protected. Protected creates a sort of trusted circle, where a class and all of its descendants can share features that should be hidden from the rest of the world.
So when do you use protected? Well, it's perfect for when a subclass needs to directly access something from its parent, but you don't want to make that thing public for everyone. It's a key tool for making inheritance work well. But here's a pro tip. A really good practice is to keep your fields private to protect your data, but then create protected methods that the subclasses can use to interact with that data safely.
Okay, let's put the official name on everything we've just learned. This entire mechanism, the static versus dynamic types, the method overriding, and Java's whole lookup process, it's called polymorphic method dispatch. And polymorphism literally means many forms, which is perfect, right? Because that's what we have. One single method call, like item.print, can take on many different forms and produce completely different results, all depending on the object's true identity at runtime. And that, right there, is the real power of this idea. Polymorphism is what lets us build these incredibly flexible and adaptable programs. We can write code that deals with a generic item and not have to care if it's a CD, a video, or some new kind of media that we invent next year. The system just works. So the real question is, now that you understand this amazing shape-shifting power, what are you going to build with it?